Hi, I'm Sterling Perrin with Heavy Reading, and I'm talking today with Nick Davey from Juniper, and we're talking about the exciting topic of 800 gig. Hi, Nick. Great to see you. Great to talk to you today.
Hey, Sterling. Happy to be here and always happy to talk about 800 gig and the latest in networking innovation.
It's coming. So yeah, great topic, great timely topic. So as we know, 400 gig market has been going on for a number of years, but now 800 gig is here as a standardized technology. The IEEE published the 800 gigabit Ethernet standard earlier in 2024, and then the OIF published in October their 800ZR implementation agreement or standard essentially for coherent 800 gig pluggable optics. So now what we have for 800 gig is standardized interfaces on both the short reach optics as well as the long reach optics for a number of applications. We're certainly seeing demand and immediate interest, even pre-standard. There was a fair amount of interest. I'm curious, Nick, from your standpoint, from Juniper, what you're seeing for demand. What applications are driving initial demand, and how is Juniper addressing the different challenges in these areas?
Yeah, I mean, whenever we take a look at a new standard like 800 gig, it always seems absolutely incredible, right? From humble origins, Ethernet now runs at 800 gig, and when we look at the applications of that technology, it really spans across all of our industries and all of our customer base. In the core of the internet, links have been bursting at the seams. We've got bundles and link eggs and ECMP groups that are already maxing out systems. So 800 gig for some providers is just providing the next logical progression, easing congestion in their WANs, simplifying topologies, and reducing the amount of protocol sessions required to just route bandwidth across cores. In other cases and in other industries, we're seeing use cases kind of evolve as 800 gig pushes the limits to what we consider a local network. When you're running at 800 gig and an incredibly low latency, concepts like what's inside of a data center aren't really fixed anymore, right? You can start stretching applications and workloads further and further because you have the bandwidth and you have these low latency networks that you can do that over. So we're really seeing a broad range of use cases for 800 gig. And then moreover than that, we're seeing 800 gig also offering higher density and more efficient ways to transport lower bandwidth circuits. So even 800 gig platforms can provide a more efficient 400 gig. So the uses and use cases are many.
Yeah, so it's I guess we've gone about maybe 3 minutes without mentioning AI, so I'll bring up the AI
Ah.
topic. How much of 800 gig demand is AI driven? Currently, and what you see just kind of in the early term.
I mean, a fair number of the deployments and use cases for 800 gig systems are AI clusters. And when we talk about stretching large stretching large high performance clusters, AI is certainly one of the main use cases for those computing clusters. Um, in AI applications, there will never be enough bandwidth, right? The applications are infinitely greedy. So in spine leaf fabrics. We're seeing 800 gig deployments. We're seeing also platforms, deep buffer platforms, for example, getting deployed in leafs and in spines in certain applications. And we're seeing network topologies change in order to offer the lowest latency and the simplest path between two endpoints. So AI is really changing the way that we design our infrastructure to simplify and to give kind of the highest performance paths between all of those endpoints. 800 gig is a huge part of that. Also, when it comes to building these huge compute infrastructures, the physical infrastructure of sites is really bursting at the seams. So 800 gig gives the ability to stretch clusters kind of beyond the four walls of a data center to where there is more space, more power, and more cooling, giving organizations flexibility in how they build their infrastructure.
Yeah, we do. I mean, kind of in my opening comments, there's the short reach side and the long reach side, and 800 gig with the full standardization covers that full scope. And you're certainly seeing both the shorter reach and the longer reach in terms of initial demand. Um, Maybe switch gears a little bit. So, we talk about the 800 gig modules or interfaces, and they're obviously critical for 800 gig, but that's not the full story. All of these modules need to be housed in a system. In the case of Juniper, you're housing them in routers. I'm wondering if you can talk to how routers, the systems needed to evolve to move from the 400 gig generation to 800 gig. Was it a big leap, or was this more kind of incremental, evolution of a routing system?
I think every time we have the opportunity to evolve platforms generationally, it gives us the opportunity to evolve those systems capabilities. And so, the heart of our high performance 800 gig solution from a routing perspective is the PTX platform. And when we look at how we've evolved the PTX platform, not just for high density 400 and 800 gig, but to tackle the types of use cases that customers are deploying those platforms into, we see more sophistication, in our protocols, more capabilities in our, say, the security infrastructure around those routers, and as well, different roles and different types of deployments. For example, we're seeing, like you mentioned before, a huge uptick in the deployment of coherent optics and in the convergence of packet and optical networks, a promise that we've been talking about as an industry for years and years. But 800 gig gives us the ability, just the raw throughput and the system-wide capability and throughput as well, to start really aggressively collapsing those roles.
Yeah. So, as a general, you don't. It's not a matter of taking the 800 gig interfaces and just putting them in a router that was 400 gig system. It sounds like these are new platforms that come to market specifically for 800 gig. Correct?
Yeah, and that's the approach we took at Juniper is to, with the 800 gig introduction, take a look at our Express silicon and say, what more can we do with these systems? Our PTX platform has traditionally seen widespread deployment in the core of infrastructure and then later on in the core of data center networks working as a spine. As the demands of those use cases increased, we've added more capabilities, things like, SRv6 support for WAN use cases, as well as a robust EVPN set of capabilities for data center use cases. And then, like I mentioned as well, security is a concept that just has to permeate everything that we do. So adding an advanced set of filtering and matching tools as well. That leads us to, an 800 gig platform. So you can plug a bunch of 800 gig stuff into it, but it also delivers on the demands of those modern networks and modern topologies, that require great deals of insight into the traffic that we're handling or, great ability to control the traffic that we're forwarding. 800 gig aggregation routers give us a lot of ability to handle raw throughput, but we can't let that turn into a black box either. And especially when you talk about AI, and I think we've given it a thorough treatment now. But when we talk about AI, there is an incredible concern about the characteristics of that traffic. So it's not just about having non-blocking 800 gig throughput on all of the ports in a platform. We need to be able to assure that traffic. We need to be able to say, what our queue depths are and what the latency is through those queues, and give application owners peace of mind that their apps and their clusters are working the way they expect. So yeah, it's
Yeah.
a lot more than just having 800 gig line rate. It's about living up to the expectations of an 800 gig platform.
Yeah, good point. It's more than just capacity. It's not just throwing capacity at the problem, which is part of it, but there's a lot of other considerations and functionality that's needed as well.
We
You,
definitely needed to start with that. You're
yeah,
absolutely right.
yeah. Understood. You did mention the coherent optics, an area that at Heavy Reading I've been looking at quite a bit over the past couple of years. In Juniper's terminology, your term is converged optical routing architecture, or CORA. I think that the generic industry term is IP over DWDM. We've done a lot of research over the past 2 years in this area. At 400 gig, as we move to 800 gig and it's commercially available, what does that mean for CORA or for IP over DWDM? What are the implications?
It means that we have no compromise routing platforms that can now act as if they were 800 gig line systems. there's something magical that happens every time we get one of these new line rates, right? For just this one brief moment in time, our physical line rate for uplinks or for WAN side interfaces exceeds what we're plugging our end stations or kind of downstream nodes in at. And that means that we can start, using that bandwidth as a fungible resource between all of the endpoints, kind of like you would in a transport network, right? In a transport system, you don't necessarily worry about bandwidth. You worry about things like channels or lambdas. You worry about having the aggregate system capacity. With 800 gig platforms, especially with non-blocking 800 gig platforms, you can start treating routers like that form of infrastructure, but with all of the programmability and control and automation tooling that you would expect from something like a router. Um, what that means in practice is that you can build very practical transport networks or very practical small topologies between local sites in a metro. And then, at 400 gig or as 800 gig long reach starts to evolve and get more and more distance in it, it means that you can build very high bandwidth, long reach transport networks as well out of your routing platforms. I'm a pragmatist at heart. I spent almost 15 years running networks as a network engineer. And there has been many, many times to just simplify topology and to give me as the network engineer more insight into how the network's running. We would take colored optics out of the line system. We would plug them into the router and we would hope that nobody noticed. That gave us the type of network that we wanted to see, and it gave us a great deal of control. And it simplified our topology as well. Right now, we just had a router plugged into a MUX, and for us, that worked brilliantly. What we're seeing is that a lot of other customers are enjoying that simplicity and finding that there's these pools, these metro networks that they can create just by building packet optical nodes and interconnecting them. And they still have their muxes, so they still have all of the channel capacity of that line system, but they have a more simplified management view just through their converged packet optical nodes.
Sure, sure. We are getting short on time. Maybe one last topic, and you did allude to it just a moment ago, which is automation, network automation, transport network automation. We've covered this topic at Heavy Reading quite a bit as well over the last 2 years. So I guess my question to you is kind of similar to the last one, but in this case for automation, what does 800 gig bring to network automation, and what does network automation bring to this evolution to 800 gig optics?
Yeah, I love the way you put it. Network automation brings to 800 gig the ability to manage transport networks like we've managed packet networks in the past. And routers just, due to the deployment of massive hyperscaler data centers, huge service provider infrastructure that we have to manage, kind of either lights out or at the end of a very long wire, have necessitated the creation of very robust automation tools and frameworks inside of routers. Most modern systems have APIs, they have client libraries. You can build incredibly robust event-driven frameworks around infrastructure now. By bringing 800 gig into routing networks, by converging packet and optical networks together, we get transport nodes that we can program like we would program our routers and our data center switches. What that means for us is that we can do really neat things to drive efficiencies. For example, we can monitor the traffic on our network and decide to take alternate paths. We can shut down links. We can optimize the topology to kind of follow the flow of traffic as people move through their day to give folks a more efficient network to run, as well as a more optimized network from a power perspective. It just gives us a great deal of fungibility in our resources to have, all the dynamic control of a routing protocol and all of the robust programmability of a modern routing system. So that's actually what I'm most excited about. I don't want to, again, betray my roots. I'm sure there's been plenty of ways that you could automate and program transport networks in the past. But for me, this is a new set of capabilities that have come to platforms that I understand. And I think network engineers everywhere are loving the idea that they can program their transport paths like they've optimized their routing protocols in the past.
Yeah, absolutely fascinating area, and a lot to be done in the next year and beyond. We are out of time, but it has been really great catching up with you, Nick, and getting your insights and Juniper's views on the evolution to 800 gig. Really great emerging area. Thanks for your time.
Yeah, no, the pleasure was all mine. Thank you so much, Sterling.
All right. Thank you.